Hi, grade 11s. In this lesson, we are going to revise some of the concepts on analytical geometry. Before we can do some examples, let us recall that if we are given 2 points, let's say this point A and this point B, the point is made up of 2 numbers. The first one is an x value and another one is the y value. Same thing with another point, you'll have an x value and the y value. So differentiate between the 2 points. So if this is the first point, so you'll have x1 and y1. If this is the second point, it will be x2, y2. Another thing that we'll be looking at the line segment that joins 2 points. Say for instance, between these 2 points, I have a line segment like that. So line segment has got n points. So it starts here and ends there. It doesn't go beyond that. So it's a line segment. You may be asked to find the gradient of the line segment. Remember that the gradient, sometimes we call it the slope of the line segment. Sometimes we call it the slope, where they talk sometimes about the steepness. How steep is the line or line segment? So the formula for the gradient is given like this. It's y2 minus y1 over x2 minus x1. Now for the lengths, meaning the length between A and B, we use this formula here. If sometimes they talk about the midpoint, the point between 2 points, meaning there must be a point in the middle there. So a point in the middle there, we will call it the midpoint. If we are talking about it, we'll be using this formula. This formula you dealt with last year in grade 10. Let's see how we do some of the problems that relates to this. Let's say we're given this problem here. They say consider the line segment AB with A, which has got minus 2:2, and B, which is minus 3:1. To make things easier, try and redraw the diagram what they're talking about. So you've got the points here and line segment. So there is A, there is B. A is minus 2 is to 2, and B is minus 3 is to minus 1. Now they say find the gradient of AB. Remember that we said the gradient, for the gradient we can use this formula here. So that's for the gradient. So m is equal to y2 minus y1 over x2 minus x1. So m is equal to, what is our y2? Remember, it said y2. So this is x1, this is y1, this is x2, that is y2. Okay, so therefore, if I say what is y2, so there is y2, which is minus 1. Minus 1, remember when you substitute, we put it in bracket, then subtract. We are subtracting y1, and y1 is 2. It's 2 over there, over. And then it's x2, and x2 is minus 3. Minus 3, we subtract x1, and x1 is a minus 2. We are subtracting minus 2. So our m value is equal to, so we can put this in the calculator so that we don't make mistakes as usual. So this bracket there, just a minus 1, minus 2, yeah. So I've minus 2, I close. So this gives me a 3, is 3. Done. The next one, find the coordinates of P, the midpoint of AB. This one we said was for the midpoint. For there, it's a point formula like this is for the midpoint, which is this one here. So to find the coordinates of P, so P will be this one. So I've got x1 plus x2 over 2 is to y1 plus y2 all over 2. So P will be, So if I substitute here, the x1 is minus 2, then plus x2 is minus 3, now over 2 is 2. y1 is 2, plus y2 is minus 1, so over a 2. So the coordinates of point P will be the answer that I would get here. So if I take this and I put it in the calculator, so it would be a minus 2 plus a minus 3 over a 2. And the answer is minus 5 over 2 here. So minus 5 over 2. And then the y value. So I'll go there. And then substitute. There's a 2 plus a minus 1. Then over a 2. Obviously this you can do it without using a calculator, but for those who always make mistakes, better that you just use your calculator so that you don't lose marks. So this one here is done. Let's look at another example. Another example says here, determine the length of the line segment that joins the points this and this. So you want to find the length of the line segment. So the line segment joins this. We said if the line joins this thing here, we use this formula here. So this formula is for the line segment. So the length, we're talking about the length, which means that we're talking about the distance. And then this is a formula for the distance, so which is d is equal to the square root of, let's put this thing here, the square root of x1 minus x2, but it is squared, then plus y1 minus y2, which is squared. So the distance is equal to under square root. Now I'll substitute the values. Alright, remember that we said this is x1, this is y1, this is x2, this is y2. So let's substitute. X1 is minus 4, then minus, I'm substituting here, so minus the x2 which is a 5, so I'm substituting a 5, then all of this is squared, plus here is this bracket. Now if I put y1 is minus 3, I must put in brackets minus 3 in bracket, then minus, and the y2 is minus 1, this minus 1 over there, but this thing is a square. So therefore the distance is equal to, plug it in the calculator. So if I plug it in the calculator, so it's a square root, then I've got open bracket and open another one, this is a minus 4, I close, then minus, then 5, then I must close this one, then I say squared, then plus, then I open, minus 3, I close, minus, bracket, minus 1, then I close, then squared. There we go. And then the answer is square root of 85, the square root of 85. Done. Let's look at the last example. It says here, M is the midpoint of the line segment that joins these 2 points. Determine the values of K and P. So M is the midpoint. If we were to draw this, it will look something like this. So M is the midpoint. M is over here, and it's got the coordinates minus 10 is to 7. Of point A, which is there, which is minus 14, is to K, and then B, which has got the points P is to 11. They want us to work out the values of K and P. So this is the midpoint. If we look at what it means when we're talking about the midpoint, to find the midpoint, let's go back to this thing here. This formula here, it says you add the x1 plus x2 divided by 2. So you add this with this divided by 2 will give you that, right? Now if I want to find that one, it means I'll have to reverse the thing. So if we do that, we write here. So for about the midpoint, we add this plus that divided by 2 will give me the middle one there. Okay, let's try. So the point here, so if I do this plus this divided by 2 will give me that, right? Let's find out. So minus 14, right, there, plus a p, so that plus that divided by 2 will give me the middle one, which is minus 10. So I'm solving for p. I can cross multiply, this goes there, so I'll get a minus 14 plus a p is equal to minus 20. So p is equal to, take this across, is minus 20 plus 14, so your p value is equal to minus 20 plus 14 is minus 6. Done. So if I want to find k, I do the same thing here. So the k plus 11, okay, let's say and k plus 11, if I divide by 2, I will get that middle number, which is 7. Solving for k, cross multiply, so k plus 11 is equal to 2 times 7, it is 14. So I take 11 now to the other side, so k is equal to a 14 minus 11, so your k value is equal to a 3. This is not difficult. It is very easy to do these problems. See if you can try your own problems which are similar to these ones from your textbook, which is a textbook, chapter 4. You do 4.1, which is just revision, exercise 4.1, then you do numbers 1 up to 7. It's very easy. Don't complete the whole thing. If you feel but we need to complete the whole thing up to, I think it's more than 7 examples there, but you can continue, but we'll do some examples later on.